Did you know the concept of relational DB, which is the foundation of most modern databases, was introduced by E.F. Codd in 1970? Database design is a rich and complex field with many interesting aspects. This is not only a technical discipline, but also an evolving field that intersects with various technological and theoretical domains. In this episode, I am going to explain you the concept of database design in detail. I am going to cover all the stages of database design. I will take you to the real-time database details, that is apartment DB, and all its possible tables. We will learn how to gather all details on tables and finally design them. At the end of this video, you would be able to understand the DB design concepts. You would be able to take up the responsibility to design new databases or optimize or change existing one in your projects. So let's go. Let's define database design first. So database design is nothing but the process of creating a detailed data model. A detailed data model that involves defining the structure, the storage, the retrieval, and the way to access the data to support integrity and efficiency. If this is a database, this may consist of various database objects. Table is not only the database object, but we have other database objects as well, like views, we have stored procedures, we have trigger and stuff like those. Those things are beyond the scope of the discussion right now, but just wanted to make you understand that there are other database objects as well. So what you do actually, you are actually evolving a process to structure the table or other database objects. And you are also going to make sure the proper retrieval process. Let's say you are trying to store the data in such a way that tomorrow if you want to retrieve them, that could be available easily for you without paying you the lots of cost in terms of storing data. I mean, if you have stored in not in a good way, or you have not designed the database properly, so what will happen? This may result into many complications in future, like you will not get the responses of data very correctly, you may not have consistent data, and integrity will not be available, and securities and other cases may occur as well. So these all things are covered under the umbrella of database design. I'm going to discuss each and every stages of database design right now, and so that you will be aware of what database design stages are. And then finally I'll take you the page where I'll already have discussed all schema details and everything, which will make you understand what kind of tables that we are going to use during our sessions and during our episodes. Okay, so the first phase is requirement analysis. In this, what happens, we gather all the details about the DB, and we also talk about the use cases. If you say use cases, it's nothing but it can be said as a scenario. Let's say you are talking about apartment DB. So what could be the use cases? The use case can be like if a new resident comes in, then what will happen? His details or her details will be inserted into the database table. So what all details that you are going to store, and how are you going to maintain those details? So this can be one of the use cases. The other use case could be like helps, house helps, their details and everything are to be maintained and managed, right? So this is a use case. So the requirement analysis may gather all details and covering all use cases. Coming to next is the diagram or conceptual design, which task in some sort of diagram. This will give a complete overview of what actually the table is. Tables are looking like, what entities are, and what are their relations. The conceptual design can be shown in a various way, like ER diagram, entity relationship diagram, or other diagrams as well, which so whatever way that makes you understand what kind of tables are there, what are the relations and objects, database objects, and what are the relations among them. Talking about the logical design, it's a normalization in case. If you say normalization, it's complete discussion of normalization is beyond the scope, but I will try to make you explain that you are creating the tables in such a way that there won't be repetition of such data. So this could be one such type of normalization. Normalizations are of different types, like first NF, second NF, third NF, like that. but the one which I told right now, that data will not be one of the normalizations. So you design the tables in such a way so that the same data is not getting repeated or duplicated. And talking about the keys, that you are specifying the relations between the tables, like primary key, foreign key, stuff like those that you decide at logical design level. Talking about the physical design stage, in this stage what happens, that you have to decide the database management system, which RDBMS or DVMS that you are going to use. Obviously you are going to use RDBMS, so whether it is a SQL server or it is MySQL or Postgre or other database management, relational database management systems. So at this stage that you decide everything, right? Indexing is such thing that you perform on the tables, so that you can retrieve data faster. And storage strategies also you can decide at this physical design level. Going to next is that you have to also consider in physical data types, like for example, if you are to store the name of the residents, so varchar type, how much size of varchar type that you should take, these things like date and time data type, or bit data type, or int data type, these things that you need to decide at this stage of database design, that is physical design, right? Going to next is implementation, wherein you actually design the schema, constant and stored procedures and triggers. So actually do things here, that is implementation. After implementation, data validation and everything, the testing is done, and finally the maintenance takes place. The maintenance is one such a stage wherein you have to take care of our database. For example, if you have created the database and designed database and tables has already been created, you have filled the data into the tables. Going forward, what happens, as long as the database is just tables are small and having less data, we will actually not be having much issues. But once the data grows, and if it grows in an exponential way, what happens then, you really need to maintain that. You need to take the backup, you need to have a recovery mechanism, you will be monitoring it, that if it doesn't crash. So these things can be, you probably need to build the indexes and everything. So these things can be covered under maintenance phase. And finally we have documentation phase. In documentation phase, you have to actually write down all the table structure details. I will be showing you all these in action right now after this discussion. And then we have security, concurrency control, etc. So these are phases of database design. I am now going to take you to the assignment one of this series, of this episode series, which will talk about all the tables that we have identified for a real-time scenario called apartment. So we are going to cover the apartment DV, which will actually take care of everything that is happening in a typical apartment. So let's go there and I will explain you all these one by one. So I am here in Google Chrome and I am typing CodeWithAbby at blogspot.com. So you know that this is our blogspot site, wherein you see that assignments here. You come here to SQL assignment and expand this, and once you hit this, you have assignment number 1. Assignment number 1 is for you now. You see that I have actually tried to show you all the table details, their structure, and what are the fields and what type of fields are there and what type of constraints that we have written. We are now well aware of the term constraints from the last episode. If you have not watched that, please go and watch that, episode number 2, wherein we have discussed this in detail. We have made master table, we have all the tables here, and then finally I am also showing you the conceptual design as the diagram here, right? You can see the diagram, correct? And this is also assignment number 1. You actually need to create these tables first in your first assignment. So I will explain you. And this is about the documentation as well. So whatever stages that we have covered in our sometimes back, every stage of the things will be covered. We are using SQL Server, that is for sure. So we have already decided that which database that we are going to use. And we are also going to do the documentation. Documentation is already covered, and we are going to conceptual design. So we have diagrams and everything, right? So every stage is getting covered. I am hoping that at the end of this discussion, you will be 100% sure about designing such data bases. Okay. I am taking the very real-time example. It's about an apartment. So there is an apartment anywhere in the world that existing. So the apartments will have many flats, and one thing that is very common in that flats that residents will be staying. So residents can be owners or can be tenants as well. And one more thing happens in apartments. Basic thing is that the help's coming. Like, so house help, like maids are coming to work in flats of the apartment. So in this, everything is covered. This keep on growing in future as well as long as we'll try to include more tables. But for now, these are all 5-6 tables that I'm going to talk about. The first thing is that flat master. Flat master is a master kind of table which hold all details related to the flat of the apartment. This has flat number, primary key, floor number that is of a small int type like 1, 2, 3, block number like A, B, C block, or anything like any block name. Areas SQFT, that is area square feet. So this is a float type which holds the area of a square feet and comments any related to flat. So this is flat master. It's a kind of master table which will hold all flat details. Going to next is the resident table. Resident table holds all resident details staying in those flats. So we have resident ID 1, 2, 3, 4. It is of a small int and primary key, so it will not be null and not be duplicate. Also we have resident name of not null. We have resident type either O or T. There would be a check there, O or T. That means either resident will be owners or tenants. O stands for owner, T stands for tenants. Flat number, it is a foreign key to flat master table, so that's why the flat number. Phone number, DOB, date of birth, there is a check condition. Again, it shouldn't be less than 18 years. Email ID, last edited. This has got default, and default is the current date. Now the users table. Users are actually the residents or tenants, and these users will be able to log into the flat application. So these users are the actually owners only. So the user ID is a small int, and it is bind to this foreign key to the resident ID. Username, password is active, date creation, and likewise. Maid master is a master table for maids or helps. It's a maid ID, maid name, sex. Sex will have the check, male, female, or undefined. Experience is like comma separated values like cleaning, kitchen work, babysitting, etc. Is active is char1 type, and it must be either Y or N. It is a check constant associated here. Date of joining is date of joining. Then we have a flat maid link. Maid flat link is the table which links maid and flat both. So flat number, this is a flat number, holds a number of flats. Which flat number? We have a maid, which is foreign key to maid master. This will also have a foreign key to flat master. So this will be mentioned here. And working since which time that flat this workings in this association. Ratings, we have ratings from 1 to 5, so there would be a check from 1 to 5 ratings. And then comments, we have any comments if any, like good behavior, etc. So these are 6 tables that I have talked about. These are all talking about a real-time scenario of apartment DB. Hope you are pretty much clear about this. I have tried to introduce most of the constraints here, and these tables are normalized, so you will not have any data duplicacy. The tables have been segregated into master and transactions as and when possible, and as much as possible. And then finally you have the diagram. You can see this diagram here. So in this diagram you see that the flat master, maid flat link, and maid master, how are they associated to each other. You can have a look on this in detail offline, right? So I am now sure that you know the concept database design, you know all the stages of database design, and I have been able to make you understand a real-time scenario of flat DB and all the tables associated with that DB. You try to write the code and the script for creating those all tables as a part of your assignment number 1. And I'm also sure that you are going to do any kind of database design coming forward in the future. Obviously, you need to put some efforts on understanding normalization, but at least you are well aware of these facts. See you in the next episode.
Subscribe for more updates. Comment or write us at mailtocodewithabby@gmail.com. Thanks for watching.